According to the National Electrical Code, the minimum size of wire for a 400 amp circuit is 300 kcmil copper wire. However, the NEC does allow for smaller wire sizes if the wire is protected by an overcurrent device that is rated for the smaller wire size. UL508A is a safety standard for industrial control panels, and it requires that the wiring in industrial control panels be installed in accordance with the NEC. To downsize the wire inside the cabinet, you will need to use a wire size that is rated for 400 amps and that is protected by an overcurrent device that is rated for the smaller wire size. The following wire sizes are rated for 400 amps. Firstly, 250 kcmil copper wire. Secondly, 300 kcmil copper wire. Thirdly, 350 kcmil copper wire. And fourthly, 400 kcmil copper wire. The overcurrent device that protects a smaller wire size must be rated for the smaller wire size. The following overcurrent devices are rated for 400 amps. Firstly, circuit breakers, and secondly, fuses. The smaller wire size must be installed in accordance with the NEC in UL508A. This includes using the proper wire connectors and bending the wire properly. You can downsize the wire inside the cabinet to a smaller size that can still carry 400 amps by using a wire size that is rated for 400 amps and that is protected by an overcurrent device that is rated for the smaller wire size. When dealing with electrical wiring and downsizing within a cabinet designed to UL508A standards and needing to carry up to 400 amps, several factors need to be carefully considered to ensure compliance with the National Electrical Code, or NEC, and safety standards. The initial wiring setup involves two 250 kcmil wires, and there's a desire to downsize the wire within the cabinet due to bending difficulties, all while maintaining the 400 amp capacity. The NEC provides guidelines for wire sizing based on ampacity, which is the current carrying capacity of a conductor. For a 400 amp circuit, the NEC typically requires a minimum of 300 kcmil copper wire. However, it's essential to consult the specific ampacity tables within the NEC, such as Table 310.15b16, to determine the appropriate wire size based on the insulation type, temperature rating, and installation conditions. These tables provide ampacity values for various wire sizes and insulation types, considering factors like ambient temperature and the number of current carrying conductors in a raceway or cable. The NEC also allows for the use of smaller conductors if they are protected by overcurrent devices, such as circuit breakers or fuses, that are rated to protect the smaller wire's ampacity. This provision is particularly relevant when dealing with short runs of wire within a control cabinet, as it allows for flexibility in wire sizing while maintaining safety and code compliance. To downsize the wire within the cabinet while adhering to the NEC and UL508 standards, firstly, determine the appropriate wire size based on the NEC ampacity tables and the specific conditions of the installation. Secondly, ensure that the chosen wire size has an ampacity rating that is sufficient for the 400 amp load or is protected by an overcurrent device with an appropriate rating. Thirdly, verify that the overcurrent protection device, whether a circuit breaker or fuse, is correctly sized to protect the smaller wire. The overcurrent device should trip or blow before the wire's ampacity is exceeded, preventing overheating and potential fire hazards. Fourthly, consider the voltage drop across the wire run, especially if the distance is significant. Voltage drop can affect the performance of equipment and should be within acceptable limits as specified by the NEC. Fifthly, ensure that all wiring and connections within the cabinet are made in accordance with UL508 standards, which cover the construction, testing, and safety of industrial control panels. This includes using appropriate wire connectors, terminal blocks, and wiring methods to ensure reliable and safe connections. Sixthly, pay attention to wire bending radii and clearances within the cabinet to avoid damaging the insulation or stressing the conductors. Proper wire management is essential for maintaining the integrity of the wiring system and preventing future problems. Seventhly, label all wires and components clearly to facilitate maintenance and troubleshooting. Proper labeling helps prevent errors during installation and maintenance and ensures that the system can be easily understood by qualified personnel. Eighthly, document all wire sizing calculations, overcurrent protection ratings, and installation details in the control panel's documentation. This documentation serves as a record of the design and installation and is essential for future reference and compliance audits. Ninthly, ensure that all personnel involved in the installation and maintenance of the control panel are qualified and trained in accordance with applicable electrical codes and safety standards. Proper training is essential for preventing accidents and ensuring that the work is performed safely and correctly. Tenthly, conduct a thorough inspection and testing of the control panel after installation to verify that all wiring, connections, and components are installed correctly and functioning as intended. This includes testing the overcurrent protection devices to ensure that they trip or blow at the correct current level. It is essential to consult with a qualified electrical engineer or inspector to ensure that the wire downsizing is done safely and in compliance with all applicable codes and standards. They can provide guidance on wire sizing, overcurrent protection, and installation methods to ensure a safe and reliable electrical system. In addition to the NEC and UL508A, local electrical codes and regulations may also apply to the installation. It's essential to check with the local authorities to ensure compliance with all applicable requirements. Downsizing the wire inside the cabinet can be a viable option if done correctly and in accordance with the NEC, UL508A, and local codes. By carefully considering wire sizing, overcurrent protection, installation methods, and documentation, it's possible to maintain a 400 amp capacity while improving wire bending and manageability within the control panel. The key considerations are firstly, NEC compliance referring to the National Electrical Code. The NEC sets the standard for electrical safety in the United States. All wiring must comply with the latest edition of the NEC. Key articles related to this situation include firstly, Article 240 covering overcurrent protection, secondly, Article 310 addressing conductors for general wiring, and thirdly, Article 408 related to switchboards and panel boards. Secondly, UL508 is the standard for industrial control panels. The panel must be built to UL508 standards, ensuring it meets safety and performance requirements. This standard dictates the acceptable wiring methods, component selection, and overall construction of the control panel. Thirdly, ampacity referring to the current carrying capacity. Ensure the wire size you choose has an ampacity rating sufficient for 400 amps. This rating depends on the wire material, insulation type, and ambient temperature. NEC Table 310.15b16 provides ampacity values for different wire types. Fourthly, overcurrent protection. If you reduce the wire size, you must protect it with an appropriately sized overcurrent device such as a circuit breaker or fuse. The overcurrent device must be rated to protect the wire's ampacity, not the 400 amp load. For instance, if you use a wire with an ampacity of 300 amps, the circuit breaker should be rated at 300 amps or less. Fifthly, wire size options. Common wire sizes and their approximate ampacities include firstly, 250 kc mil copper approximately 255 amps to 290 amps depending on insulation and temperature rating. Secondly, 300 kc mil copper approximately 285 amps to 320 amps. Thirdly, 350 kc mil copper approximately 310 amps to 350 amps. Fourthly, 400 kc mil copper approximately 335 amps to 380 amps, and fifthly, 500 kc mil copper approximately 380 amps to 430 amps. The ampacity values can vary based on the specific insulation type THHN, THWN, etc. and temperature rating 75 degrees Celsius or 90 degrees Celsius. Sixthly, short run exception. Given the short run of 11 inches inside the cabinet, you might be able to utilize the tap rules or other exceptions within the NEC that allow for smaller conductors over short distances, provided they are properly protected. Consult NEC 240.21 for tap conductor rules. Seventhly, termination temperature. Ensure that the terminals in the panel and the overcurrent protection device are rated for the wire's temperature rating. For example, if you use a 90 degrees Celsius rated wire, but the terminals are only rated for 75 degrees Celsius, you must use the 75 degrees Celsius ampacity. Eighthly, voltage drop. For such a short run, voltage drop is likely not a significant concern, but it's always good practice to verify, especially if the panel is located far from the source. Ninthly, professional consultation. Due to the complexities and safety implications, consult a qualified electrical engineer or licensed electrician. They can perform the necessary calculations and ensure compliance with all applicable codes and standards. Tenthly, documentation. Keep detailed records of all changes made to the wiring, including wire sizes, ampacities, and overcurrent protection device ratings. This documentation is crucial for future maintenance and inspections. Examples of possible scenarios. Firstly, Scenario 1, using 300 kcmil copper wire. If you choose to use 300 kcmil copper wire, ensure it has an ampacity of at least 285 amps to 320 amps depending on the insulation type and temperature rating. Protect it with a 300 amp circuit breaker or fuse. Secondly, Scenario 2, utilizing tap rolls with 250 kcmil copper wire. If the NEC tap rolls permit, you might use 250 kcmil copper wire, but ensure the overcurrent protection is appropriately sized to protect the 250 kcmil wire's ampacity, typically around 255 amps to 290 amps. In summary, downsizing the wire is feasible if you adhere strictly to the NEC and UL508A standards. Always prioritize safety and consult with qualified professionals to ensure compliance. The key is properly protecting the reduced wire size with an appropriately sized overcurrent device. It's crucial to note that electrical codes and standards are subject to change and interpretations can vary. Therefore, consulting with a qualified electrical engineer or inspector is essential to ensure compliance with the latest requirements and local regulations. Additionally, it's important to consider the specific application and environmental conditions when selecting wire sizes and overcurrent protection. Factors such as ambient temperature, humidity, and exposure to corrosive substances can affect the performance and lifespan of electrical components. Regular inspection and maintenance of the electrical system are also essential to ensure continued safety and reliability. This includes checking for loose connections, damaged insulation, and signs of overheating. Any issues should be addressed promptly to prevent potential hazards. Furthermore, it's important to educate personnel who work with or around electrical equipment about the potential risks and safety precautions. This includes providing training on proper lockout/tagout procedures, personal protective equipment, and emergency response protocols. By implementing a comprehensive safety program, it's possible to minimize the risk of electrical accidents and injuries. In conclusion, downsizing the wire inside the cabinet is possible, but it requires careful consideration of various factors and strict adherence to electrical codes and standards. By working with qualified professionals and implementing a robust safety program, it's possible to maintain a safe and reliable electrical system while optimizing wire bending and manageability within the control panel. This approach not only ensures compliance with regulatory requirements but also enhances the overall efficiency and safety of the electrical installation. Moreover, it's important to stay informed about any updates or revisions to electrical codes and standards. These changes can impact wire sizing, overcurrent protection, and other aspects of electrical design and installation. Subscribing to industry publications, attending training seminars, and participating in professional organizations can help electrical engineers and electricians stay up to date on the latest developments and best practices. In addition to technical considerations, it's also important to consider the economic aspects of wire downsizing. Smaller wire sizes may be less expensive than larger wire sizes, but it's important to weigh the cost savings against the potential risks and limitations. For example, using a smaller wire size may require more frequent inspections and maintenance to ensure that it's not overheating or deteriorating. Ultimately, the decision to downsize the wire should be based on a comprehensive analysis of all relevant factors, including safety, code compliance, performance, and cost. By taking a holistic approach to electrical design and installation, it's possible to create a safe, reliable, and cost-effective electrical system that meets the needs of the application. Furthermore, it's important to consider the long-term implications of wire downsizing. While it may provide immediate benefits in terms of wire bending and manageability, it could also lead to increased maintenance costs or reduced system reliability over time. Therefore, it's essential to carefully evaluate the potential trade-offs and make an informed decision based on the specific requirements of the application. In addition to wire sizing and overcurrent protection, it's also important to consider the type of wire connectors and terminals used in the control panel. These components must be compatible with the wire size and material and must be installed correctly to ensure a reliable electrical connection. Using the wrong type of connector or terminal can lead to loose connections, overheating, and potential fire hazards. Therefore, it's essential to select high-quality connectors and terminals that are specifically designed for the application. Finally, it's important to document all aspects of the electrical design and installation, including wire sizes, overcurrent protection ratings, connector types, and installation procedures. This documentation serves as a valuable resource for future maintenance and troubleshooting and can also be used to demonstrate compliance with regulatory requirements. By maintaining accurate and up-to-date documentation, it's possible to ensure that the electrical system remains safe, reliable, and compliant throughout its lifespan. In conclusion, downsizing the wire inside the cabinet is a complex task that requires careful consideration of various factors and strict adherence to electrical codes and standards. By working with qualified professionals, implementing a robust safety program, and maintaining accurate documentation, it's possible to achieve a safe, reliable, and cost-effective electrical system that meets the needs of the application. It is important to note that this information is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer or inspector before making any changes to an electrical system. They can provide guidance on wire sizing, overcurrent protection, and installation methods to ensure a safe and compliant electrical system. Additionally, it's important to stay informed about any updates or revisions to electrical codes and standards. These changes can impact wire sizing, overcurrent protection, and other aspects of electrical design and installation. Subscribing to industry publications, attending training seminars, and participating in professional organizations can help electrical engineers and electricians stay up to date on the latest developments and best practices.